Okay, these next set of directions say solve each equation over the set of real numbers, show all work, answers must be in simplest form, be sure to cross out any extraneous solutions. Recall that extraneous solutions are solutions that do not work. Okay, so you have to check your answers here, either by hand or using the calculator as I've shown you in class. Okay, so step one to solving an equation with a radical in it is to isolate the radical. So we need to make sure that we get the radical on one side of the equation by itself. In 17a, it is already by itself, so step one is complete. Step two says, well, get rid of the radical. Well, the radical is a cube root, so what gets rid of a cube root is cubing both sides. So I will cube both sides, meaning raise it to the third power. The cube root cubed will cancel because they're inverse operations, and I will bring down 2x minus 4. And then the other side, negative 2 cubed, is negative 8. You're left with an easy equation to solve, so we just solve it. So add 4, divide by 2, and your possible answer is x equals negative 2. You will need to check it. I will show you this one time how to check it by hand, but you can use your calculator as I've explained as well. So the cube root of, I'm going to replace negative 2 where the x is, so I get 2 times negative 2 minus 4. So when I do this work here, I get the cube root of negative 4 minus 4, which is the cube root of negative 8, which is indeed negative 2. So you see it does check, so this is the answer. Okay, 17b. Step 1, isolate the radical. So in this case I will have to subtract 2 first. That gives me 5 square root of x equals 10. And it's still not isolated. I need to divide both sides by 5, so I get the square root of x equals 2. Now that the radical is isolated, I can get rid of it. Since it's a square root, what gets rid of a square root is squaring. So I will square both sides. Square root of x squared is just x, and 2 squared is 4. If you plug that into your calculator, you will see, or by hand, and you will see that 4 does indeed work, so it is a valid solution. Okay, let's try C. To isolate the radical in C, the first thing I have to do is subtract 7. The square root of 2x plus 1 equals, when you subtract 7, negative 3. And some of you know that this may be a problem later on, and we'll see what happens. If you recognize that it is a problem, you can go ahead and write the answer at this point, but we'll continue the problem from here. To get rid of a square root, we square both sides. So this gives me 2x plus 1, and on the other side, negative 3 squared is positive 9. So let's solve this equation. Subtract 1, divide by 2, and the possible answer here is also 4. The problem is when you plug it back in and check, 4 does not work. If you plug 4 in, you get 2 times 4 is 8, plus 1 is 9. Square root of 9 is 3. Well, 3 plus 7 is 10, not 4. So this answer does not work. So according to the directions, I have crossed it out. But what would then the answer be? What would it be if we no longer have any answers? Well, it would be no solution. Okay? If there was still another answer that did work, that would be the answer. But since there are no other options, the answer is no solution. Okay, we'll solve problem D. Isolate the radical, so I'm going to add x to both sides. That's going to give me x plus 3 equals the square root of 3x plus 7. To get rid of the radical, it's a square root, so I'm going to square both sides. Well, this side is easy. It's just going to be 3x plus 7. But the other side, we have a binomial squared. Remember, that means to FOIL it. If you don't FOIL it, you're going to miss the middle term. It comes out to be x squared plus 6x plus 9 when you FOIL it. Okay, since we have an exponent in our answer here, to solve this equation, we need to set everything equal to 0. So I'm going to subtract the 3x and subtract the 7. This gives me x squared plus 3x plus 2 equals 0. And we now factor this. Factors of 2 that add to give you 3 are positive 2 and positive 1. Set each factor equal to 0 and solve. So the possible answer for this factor is negative 1 and for this one is negative 2. So you have two possible answers for this particular radical equation. You need to check both. In this particular case, both of them work. So you would write your answer in solution set form, and it doesn't matter if they're not in order. Okay, last problem of this type. Let's isolate the radical by subtracting 10. And you'll notice that that gives us the square root of 3x plus 7 equals negative 6. Well, back in problem C, we saw that the square root equals a negative was a problem. Well, we know that we can't have the square root equal to a negative, so we're probably going to come up with no solution here as well. But if you looked at problem A, we had the cube root equals a negative. Remember, an odd root can equal a negative, so that's not a problem. But here, for an even root, as in letters C and E, problem C and E, those are even roots trying to equal a negative, and that's not possible under the set of real numbers. So let's continue to work it. We know that the answer should come out to be no solution, but we'll verify that. The square root squared is 3x plus 7. Negative 6 squared is 36. Solve this, so I'm going to subtract 7, divide by 3, and my possible answer is 29 thirds. When you plug it back in, 3 times 29 thirds is 29, plus 7 is 36, square root of 36 is 6, plus 10 is 16, not 4. So this answer does not work, and again, since there isn't another answer to choose from, it is no solution.